So in this lesson, I want to talk about direct and partial variation and what that means when you're looking at a relationship between variables. So in every relation, if we decide that there is a relation, we know that when one variable changes, the other variable is going to be affected in some way. So let me explain what I mean. We've been looking at distance versus time graphs, and we can see that as the time increases, the distance increases, right? So that's a case of we see a direct relationship, okay? Let's look at this graph of population versus time, right? So as the years go on, it looks to me like the population is increasing, but it's not increasing at a steady rate like we saw in this distance time graph. There's a curve of best fit. This last graph, we can see that I'm looking at the value of a car as the vehicle ages, right? And so it's not a linear relationship, but we can see that as the vehicle gets older, its value becomes lower and lower. So those are three examples of relationships where as one variable changes, the other one is affected. All right, so what I want you to do right now is to take a guess. Only one of these four graphs represents what we call a direct variation. And all the other types, all the other graphs are different types of variation. So take a guess by looking at the graph. Pause the video, and then I'm going to let you know. All right, so hopefully you had an opportunity to see which one of these is not like the others. Okay, some of you may have picked the green graph, but you would be wrong, even though it is the only one with a negative slope. The only graph with a direct variation is this blue one right here. And the reason I can say that is because the graph starts at 0, 0, and then as my x variable changes, my y value changes as well. But more about that in a minute. So what do we mean by direct variation? We mean that as one variable is changing, the other one is varying directly with it. So let me give you some more concrete examples so that this can make sense to you, right? So and a good example we've already seen is that the distance traveled will vary directly with time. So for instance, if there's no time gone by, I would not have traveled any distance. So I can see that my y-intercept is at 0. If we're talking about a situation where you're earning an hourly wage, and see there are different color lines here representing the different wages that people are making per hour, right? So for instance, if you're a plumber, you're making 60 bucks an hour. So I can see here that, in this case, none of these people are earning any flat rates just for showing up. So if they don't work any hours, they're not earning anything at all. So again, my y-intercept is at 0. So let me talk a little bit more about that. So if we write an equation of a line, we know that it's written in the form y equals mx plus b. And of course, we can change the variables from x and y to other variables that might make sense in the situation, but that's not necessary as long as you let the reader know what you're talking about. So in this case, what is my y-intercept? What is the value of b? Well, the value of b is 0. So really, in a direct variation, if my y-intercept is always going to be 0, then the equation always takes the form y equals mx plus 0, or just simply y equals mx, right? So in this case, I can tell that the hourly wage is my slope. So if I was talking about what a lawyer would make for as wages, and I wanted to make this graph into an equation, I would simply replace the m value with the 300. So y, my earnings, would be equal to 300 times x, and x being the number of hours that I worked. But there would not be a y-intercept. So another example would be an example of a direct variation would be the circumference of a circle. Remember, the circumference is the distance all around the outer rim of that circle. we're saying that it varies directly with the radius. So in other words, as the radius increases, so does the distance around that circle. And that makes sense because the larger the radius, the more distance you're going to have to cover around the edge of that circle. But also another way to think about it is that if I have a circle with no radius, then I don't have any circumference, right? So if I'm looking at the graph of this function, then it should make sense to you that the y-intercept is going to be at 0, 0 again, right? No radius, no circumference. So hopefully that gives you an idea about how to tell on a graph and in an equation about whether you're looking at a case of direct variation. So now then, well, what makes a partial variation different than a direct variation? Well, the difference is that with a partial variation, one variable is only changing partially with the other. So we can usually identify that by the fact that there might be a fixed value associated with one variable, right? So let me look at an example with you. So an example of a situation that we would consider to be a partial variation would be one like a car rental charge, where there's a basic daily rate plus a charge for the number of kilometers driven, right? So I can tell here that from the graph of this function that this is not a direct variation. It's only a partial variation because my y-intercept is not at 0, 0. There is an initial or a fixed value at the beginning, right? And then after that point, I see y varying with x. So that's just one example. Let me talk about a couple of others. So a second example of a partial variation is one where I'm looking at a salesperson's income, but in this case, they're not simply making an hourly wage, just, hour by hour. They're getting some sort of flat value at the beginning, in this case, $100, and then they're getting a certain amount of money after each sale that they're making. In this case, it's television. So again, I can tell that in this case, this is not a direct variation, it's a partial variation. So let's look at the equation for this particular situation. So the equation of a line in slope-intercept form, you'll remember, is y equals mx plus b. And I'm going to keep the variables with y and x, even though there may be others that would be suitable. So in this case, though, my y-intercept b is not 0, it's 100. So instead of having 0 as my y-intercept, I'm going to see that there actually is a value other than 0 for my y-intercept, right? And then from there, I would go ahead and I would say, all right, well, what is my slope? Well, it looks to me like they went from $100 to $150 after one television was sold. So that to me tells me that they're making $50 per television after the initial $100 that they're making, right? So that tells me that my slope in this case is $50, right? $50 per television set sold, right? So the structure of the equation is going to take on the full form y equals mx plus b, and the value of my y-intercept is not going to be 0. So now I want to talk about, just to sum it up, how if you're looking at a question and the question asks you, is this situation an example of a direct or a partial variation? How you're going to analyze that and answer it appropriately based on the information that they give you. So if you're looking at the graph of a situation and you're asked whether it's direct or partial variation in that case, you're going to look and see very carefully about where your y-intercept is. So in a direct variation, your y-intercept is going to be 0 and you're going to have y increase as x increases. Right? Conversely, on the other hand, if you have a partial variation, you're not going to see your y-intercept at 0, 0. You're going to see the line increase at some other fixed value up here. Okay, so next, let's see how we can apply that to a table of values. So remember over here, when I was looking at my y-intercept, you'll remember that, the y-intercept was at 0, 0, right? So if I'm looking at a table of values, I want to find out where the y-intercept is, I want to know, well, what is the value of y when x is 0? Because that's the definition of a y-intercept, the value of y when the value of x is 0. Well, if it's a direct variation, then I'm going to see the graph crossing at 0, 0. And so that's what I would look for in a table of values for direct variation. Let's look at partial variation. So again, remember the value of x, here's my x-axis, the value of x is still going to be 0. It's just that the value of y is not going to be 0. So I'm going to look to see where x is 0, and I'm going to look to see if there's a value other than 0 for y. So for example, let's say I said this was 5, then I would expect to see 0 and some other number, in this case 5. And the rest of the table of values would be filled in however. All right, so lastly, we spoke about what the equation of a linear relation would be if it's a direct variation. We said that it would be it would take on y equals mx plus b form, except that b, the value of b would be 0. And so I would be looking for an equation that didn't have a value indicated for my y-intercept. So instead of having y equals mx plus 0, I would just have, because usually you won't see that, I would have mx alone, right? Okay, and on the other hand, if it's a partial variation, what I'm going to see on my graph is I'm going to see the equation of a line with a value other than 0 for my y-intercept. So, oops, let me erase that. So y equals mx plus b. So there will actually be a value given for my y-intercept. And that's all, folks. So I've pulled out a question from the EQAO, a past EQAO exam, and I just want to go through it with you. So in this question it says, at her fitness club, Joanne is charged $15 per month. The total cost for 12 months is $270. So in this example, the question wants us to know the relationship between the cost and the number of months, a direct or partial variation, and what is the initial fee. All right, so it looks to me like when I look at this, I can see that she's just charged a plain old $15 per month. So if she's actually working there for 12 months, then 12 times 15, if there's no initial fee, should cost me $270. So let's check that out. So it turns out that 12 times $15, because she's paying $15 a month, actually gives me $180. So that tells me something about the situation. If she's actually paid $270, then there must have been an initial fee, right? And the initial fee would be the difference between $270 and $180, because that $180 really only represents the amount that she paid for her monthly fee. So in this case, I know there's a starting value. That would be my y-intercept. And I know that the starting value would have to be the difference between 270 and 180, which happens to be $90. Right? So right off the bat, I know that it cannot be a direct variation if there's an initial fee, because that just does not make sense. And I also know that it can't be a direct variation if there is an initial fee at all, so I can get rid of this $0, right? So my leftover choices are, is it partial variation with a $15 or a $90 initial fee? And the answer, of course, when we say 270 minus 180 is that the initial fee is $90. And so there I've been able to figure out what the solution is there. So don't just take for granted that because they're telling you, they're not telling you about the initial fee, that there isn't one. You have to dig a little deeper to figure that out. So here's another question where it's not a question specifically about partial and direct variation, but I think it's interesting and it's related to that. So we talked about how to tell a direct and a partial variation from a table of values. So when I look at this question, and I'm just going to read it really quickly here, what it says is the table below shows a relationship between the cost to rent a bicycle and the number of hours. So I know that at 0 hours, the cost is $10. So what that tells me is that this in fact is a partial variation, and that my graph is going to have a y-intercept at 10, right? So that's what this total cost is right here. So that tells me that I should be able to tell right off the bat by looking at each of these equations which of them cannot be the answers to this problem, because at 0 hours I don't have 0 rental cost. So this is not a direct variation. This is a partial variation, right? But it also tells me that my y-intercept is 10. And so remembering that an equation of a line is written in the form y equals mx plus b, my slope is the part of this equation that is right next to the variable x, or whatever the variable is. But the part of the equation that is all by itself and does not vary, the fixed part, is my y-intercept, and that happens to be 10. So that tells me that my cost is going to be 10 plus 3n. So that's telling me that it's $3 for every extra hour that I'm riding the bike. Hope that helps with partial and direct variations. Make sure to ask me questions if you have any. I'll be happy to help you out.